It's impossible to avoid them. For decades, we've been surrounded by sweet and fatty foods, and the body has not been dealing well with these eating habits. But what about the brain? Do our mental health, our moods, and our brain abilities suffer from the wrong kind of nutrition?
We know that junk food is making us fat, but science is telling us now that it might also be shrinking our brains.
Brain researchers have joined the dining table to study the effects of our eating habits.
Diets that are high in fat and sugar in the long term lead to changes in part of the brain involved in memory.
This is a recent field of research, a developing science that spotlights a new facet of nutrition.
Habitual intake of foods high in fat and sugar result in a reprogramming of the brain.
In short, our brain is affected by what's on our plates. It all starts with our very first meals, even before birth. The brain is built up during pregnancy. How it functions later on depends on how it has been nourished by the expectant mother's diet over 9 months. A number of consequences of poor nutrition during gestation have been known for a long time. Today, scientists in Australia are looking at the repercussions of nutrition on brain function. Felice Chaka, a professor at the University of Melbourne, examined the behavior of babies after following the eating habits of 23,000 pregnant women.
We measured their intake of junk and processed foods. We measured their intake of the healthful foods, foods with lots of fibre and nutrients, etc. And then we looked at the emotional health of their children over the first few years of life, from 18 months to 5 years. Of course, taking into account things such as education, income, the mother's mental health, parenting practices, these sorts of things. And what we saw very clearly was that mothers who ate more junk and processed foods, so sweet drinks and salty snacks and, cakes, biscuits during their pregnancy, their children had more of these behaviours such as aggression and anger and tantrums.
This disquieting correlation suggests that the mother's diet impacts the mental development of the baby, though the link remains to be demonstrated on the biological level. In any case, Felice Chaka is convinced.
So what we also saw in this large Norwegian study is that the children's diets seem to be important as well, independent of what mum ate. If children were eating too much junk and processed foods and or not enough of the healthful foods, they had more of these anger and aggressive type behaviours, but also sadness, anxiety, worry, nightmares.
Since then, Professor Chaka's conclusions have been confirmed by studies in Spain, the Netherlands, and Canada. Excess fat and sugar are now in the sights of scientists working on the brain. Excesses and deficiencies. Junk food is often low on essential nutrients, so it leaves the body, and especially the nerve cells, lacking. In this laboratory at the University of Bordeaux, scientists are studying the consequences of dietary deficiencies on mouse brains. This experiment is used to measure anxiety. The animal has the choice between exploring the lighted area or hiding in the shade. A normal mouse takes the time to examine the lighted area. But this animal was deprived of omega-3 fatty acids during its development, Omega-3s are called good fats due to their benefits to the heart and arteries. Instead of exploring the environment, the mouse takes refuge in a dark corner. It's stressed, anxious. The experiment has been reproduced many times on dozens of mice. For researchers, this strange behavior can be simply explained. Without omega-3 fatty acids, the brain does not develop and function normally. They're needed because the brain's gray matter is 90% fat, which it cannot produce itself.
The brain is the organ after adipose tissue that's the richest in polyunsaturated fatty acid, or omega-3. So omega-3 is indispensable because the body cannot make it. We have to ingest it. It has to come from the diet.
Oily fish, organ meat, vegetable oils, and seeds and nuts such as almonds have long been the main sources of omega-3 for humans. But these foods have become scarce in the cuisine of industrialized countries. The amount of omega-3 that enters the brain is crucial for making brain cells more efficient, because when these fatty acids are incorporated into the membranes of nerve cells, they improve their electrical properties. In omega-3 rich neurons, the signals propagate faster. The network is more efficient. Depriving the brain of omega-3 is linked to a risk that it will function less well.
The general population is deficient in omega-3. We have insufficient intake of omega-3, so it's important to pay attention to it, especially in the prenatal developmental period. During this period, omega-3 embeds itself in massive quantities into the brain. Also in adolescence, when there's often a change of food, and during aging, where the incorporation into the brain of omega-3 tends to be less effective, so we must increase its intake.
The first rule for a brain to run at full speed is avoid deficiencies. But good nutrients and a varied diet should be available. What happens to neurons when meals are poor and, above all, always the same? That is a problem that is now affecting the wild-living European hamster, which thrived for a long time in the plains of France's Alsace region.
Since the 1960s, there's been a decline in the hamster population, which is on the verge of extinction today. And at the same time, we've noticed an increase in the agricultural area where corn is cultivated.
Caroline Abold wondered whether the collapse of the population was linked to the sudden glut of corn. So she did an experiment, feeding hamsters exclusively corn.
During breeding, we observed behavioral disturbances in females, which resulted in hyperaggression and hypersensitivity as soon as there was noise in the room. Above all, what we did not expect is that these females would devour their young the first day after birth. This behavior was observed in more than 80% of females.
A dietary deficiency was enough to make a hamster devour its children. The cause? A simple vitamin.
A vitamin B3 deficiency is at the origin of the abnormal behavior. When we supplemented them with vitamin B3 in addition to their corn-based diet, they expressed quite normal behaviors. And they began to nurse their young, to raise them in the same way as the females that were fed a diversified diet.
The case of the cannibalistic hamsters is disturbing. Could an unbalanced diet also trigger aggressive, violent behavior in humans? Ab Zaalberg is a clinical psychologist and political advisor to the Dutch Ministry of Justice. His specialty? Nutrition and crime. He's convinced that enriching food with vitamins, fatty acids, and minerals can reduce aggression. It's a hypothesis that is difficult to test in normal life because so many factors and circumstances can influence our behavior and our impulses. In order to study nutrition without the influence of the many parameters, he chose prisons as a nearly ideal setting.
Here, in the Netherlands, we conducted a study of young prisoners in 8 different prisons. For 3 months, we gave them vitamins, minerals, and fatty acid supplements. And then we looked at the effect on their behavior. We measured it in 2 different ways. First, we asked the detainees how aggressive they were, and we asked the supervisors for their views on the issue. Above all, we looked at the incident log, the number of times detainees were punished, and we saw that solitary confinement had fallen dramatically.
In the group of inmates whose meals were improved, the number of incidents was reduced by 1/3. What we eat may have the power to change our moods, to stimulate certain impulses. But could the food on our plate also influence our decisions? The ones we believe we make using our free will.
When people are asked if they think that the food that they eat has an impact on health, most answer yes. But when asked if diet can also influence thoughts and decisions, very few people are willing to believe this is the case.
Das können sich viele Leute nicht vorstellen.
However, at the Institute of Psychology of the University of Lübeck in Germany, Professor So-Young Park has, for the first time, proven it. Her work reveals the mechanism by which food could influence our thoughts. And for that, the researcher has developed a rather original experiment. Imagine that you face the following dilemma. The money on the table is to be divided into 2 sums. But it's your partner, a stranger, who decides how it is to be distributed.
I give you €2 and I keep 8 for me.
If you accept the unfair offer, you leave with a little money, but much less than your partner's. If you refuse, no one wins anything. So what would you do? Do you accept the offer and take the €2 even if you feel cheated? Or do you refuse and leave with empty pockets, but your head held high? Well, it turns out, surprisingly, that whether you'll take the money or not depends on what you've just eaten.
As part of this study, we followed 24 people who came into the laboratory twice to have 2 different breakfasts. We found that the same person made completely different decisions based on what they ate in the morning.
To the test person, the 2 breakfasts look the same. In reality, one is far more protein-rich than the other. The ratio of protein to sugar is the only parameter that changes. A few hours after the meal, the subject takes several tests on a computer. Today, he accepts the offer. His self-interest outweighs his anger at the unfairness, and he will leave with a little money in his pocket. Last week, he mainly refused and won almost nothing.
The subject, having consumed a high-protein breakfast in the morning, was tolerant of unfair offers. Conversely, the subject who consumed a high-carbohydrate breakfast was less tolerant in the face of unfair offers.
On average, the subjects who had little protein rejected unfair offers twice as often. But how can this surprising result be explained? In their search for biological evidence for this observation, the scientists carried out blood tests.
We will send the blood to the laboratory for analysis. We will measure the level of hormones and amino acids in the blood. For hormones, we are interested in insulin, cortisol, adrenaline, and adrenocorticotropic hormone. And for amino acids, tryptophan and tyrosine.
Of these substances, the most important is tyrosine. The amino acid is one building block of a protein that is key to brain function, dopamine. This molecule ensures communication between neurons involved in motivation and risk-taking. The results of the blood analysis show that subjects with higher levels of tyrosine in their blood are more willing to accept the unfair offer. In other words, what we eat can within hours subtly alter the chemistry of the brain and thus the communication between the neurons. Enough to guide some of our decisions. Experiments are continuing in Lübeck to confirm this result. The implications are wide-ranging.
Since we eat 3 times a day, every day, we realize that food has immense power, that of modifying and shaping mankind. So it's essential to think about how we can use food to promote our well-being and optimize our mental state.
Not only does an unbalanced diet affect our brain functions and behavior, and our meal plan interfere with daily decisions, it also becomes increasingly clear that diet plays a decisive role in our mood and possibly mental health. But what about junk food, dripping with sugar and bad fats? What would happen if we ate more of that? This is the focus of research here in Australia at the University of Sydney. Margaret Morris runs a laboratory where rats are fed the kind of junk food that you find in supermarkets or cheap fast food restaurants.
Our experiments use a range of Western foods of the type eaten by all of us. So we feed our rats meat pies, chips, cakes and biscuits, the sorts of foods that are readily available and cheap. So we are modelling the Western world.
The first consequence of this diet, the rat doubles its food rations. The animal never seems satiated, but that's not the most surprising outcome.
One of our chief interests is the impact of this diet on the animal's memory. And we can measure this easily in the rat using a task known as the novel object and novel place task.
In this test, the researcher places objects in the rat's cage. The animal comes over immediately to examine them. Rodents are very curious by nature. Once it's completed its examination and memorized its surroundings, it's temporarily removed.
We then place the animal in the arena with one object that's been shifted.
On its return, the rat spends more time examining the object that has changed places because it already knows the other objects. They're engraved in its memory. The rats stuffed full of bad foods behave differently.
What we observed is the animals eating a high-fat diet or a high-sugar diet or the combined high-fat, high-sugar foods were less able to recognise, to remember that that object had moved. They explored the two objects about the same. That shows an impairment of their spatial memory.
The overfed rats have not only damaged spatial memory, but also other malfunctions that sound a warning signal for the scientists. They point to damages in the hippocampus, a small region nestled in the center of the brain. It's essential for learning and the consolidation of memory. Recent studies show that in humans, a too energy-rich diet also interferes with the hippocampus.
We see, for example, that the quality of people's diets is related to the size of their hippocampus, to the size of their grey and white matter volume, and there's starting to be intervention studies. So, for example, we see that only 4 days on junk food type diet will have an impact on cognitive functions that are related to the hippocampus.
Margaret Morris is now seeking to understand how sugary and fatty foods disrupt the brain of her rats to the point of affecting their performance. She has a hypothesis, namely, eating too much fat and sugar triggers an inflammatory reaction that spreads to the neurons.
So, in response to these foods, there's a general inflammatory response all around the body. This has been well described in obesity, but it now appears to be quite an acute response as well. And what we find is that inflammatory molecules such as cytokines are increased in response to the diet.
An overly rich diet confuses the immune system. It responds by triggering an inflammatory reaction, especially in fatty tissues. Our fat masses release substances that then propagate this inflammation throughout the body. Neurons were thought to be spared this effect behind the protective blood-brain barrier, the semi-permeable membrane that separates the circulating blood vessels from the brain.
So there's increased inflammation in the whole of the body, and we think that this may spread to the brain. That's because the blood-brain barrier, which normally protects the brain from inflammatory molecules, may be impaired, in fact, by the diet and become leaky, allowing traffic of molecules into the brain.
The inflammation infiltrates the meninges and then triggers a surprising phenomenon. In her laboratory, Sophie Ley has shown in her overfed mice that certain immune cells in the brain, the microglial cells, begin to devour neurons.
These microglial cells within the brain are important because they can eat dead neurons. But when they're deregulated, especially in a situation of unbalanced nutrition, they start to eat neurons that are alive. Therefore, by consuming these neurons in excessive numbers, eventually they will destroy or participate in the destruction of neural networks. That includes neurons that are alive and that should be functional.
This reaction of the microglial cells could be filmed in vitro. The images show how energetically they move. The red objects are fragments of neurons that they ingest. In an obese mouse, the activity becomes frenetic. This phenomenon is suspected of significantly affecting the functioning of the brain.
We've been saying to people for 30 years, don't eat these foods, you might have a heart attack, you might get cancer and diabetes. It hasn't worked to change people's behaviour. We hope that if people understand that what they put in their mouth is actually really essential to the health of their brain and that of their children, that might have a more profound impact on people's dietary choices.
Microscope, micromanipulator, and ultra-sensitive recorder. Xavier Fioramente is at the helm of an apparatus that can record the electrical activity of a single neuron. The principle is simple. A slice of mouse brain is immersed in a liquid that keeps it alive. The researcher approaches it carefully with an electrode. It's a meticulous operation.
Here I go down the pipette in the slice of brain. And now we will approach this recording pipette near the neuron to make contact. That's it, we made contact. And now we will be able to measure the electrical activity of the neuron. The upward peaks that we see are potential areas for action. This is how neurons encode information.
The time that elapses between the peaks is the message sent by the neuron.
Now we will increase the glucose concentration in the bath, and we will see if this cell responds to this increase in concentration of glucose. As it can be seen here, this cell responds to the increase with more electrical activity. There is more potential for action than what could be seen here before the increase in glucose concentration.
This signal comes from a single cell, but in the brain, the neurons are all connected to each other. That makes the scientists suspect that glucose has the ability to modify the activity of entire brain areas that control emotions and pleasure. Is this how sugar ensures its grip on our will? This is, for the moment, only a hypothesis. But today, sugar addiction is the subject of intense research in laboratories. And what appears more and more clear is that the power of sugar is similar to that of a drug. Serge Ahmed is one of the first to provide proof with a very simple experiment. Step 1, he raised rats, giving them cocaine and sugar. Then, after weeks of this diet, he presented the animals with a choice.
We have the situation in which the animal has the choice between a lever that is connected to a syringe that contains a drug solution, and the drug in question is a hard drug like cocaine and heroin, and on the left, a lever allows him to control a syringe that contains a sweet drink. And there we see the animal chooses to take the sweet drink.
The rats selected the sugar water 4 times more often than the drugs. It can't be called a glucose overdose, but the irrepressible desire is plain to see.
So this experiment simply shows that sugar has more addictive potential than we had imagined, and it is perhaps even stronger than the pull of hard drugs, such as cocaine and heroin. Today, we live in a food environment that's a little crazy. We find sugar in a lot of foods, as we would expect, in sugary drinks. But we also find sugar in foods that are not meant to be sweet, such as ham or soup. We could cite other examples, but it's adding sugar to these foods that contributes to the fact that we make people addicted to it without them knowing it.
Here at the Oregon Research Institute, the influence of sweet food on the human brain is being investigated.
What this program of research has revealed is that habitual consumption of energy-dense food alters your neural circuitry in exactly the same way of consumption of drugs of abuse.
Eric Stice recruited about 100 students, half of whom regularly eat ice cream, while the others never eat it. They all came to the laboratory to drink a milkshake inside an MRI device and give the researchers a peek into their brain activity.
Great, Casey. So what we're going to do today is give you chocolate milkshake and record the brain activity in your entire brain as you receive and anticipate receiving chocolate milkshake to look at the neural basis of consuming energy-dense foods.
The test subjects can sip the milkshake through the tubes without moving their heads.
What we found out is that the people who never eat ice cream, you could trace the reward circuitry, everything lit up just beautifully and it activated things very strongly. But in contrast, the people who ate ice cream every day showed a very diminished response. There was hardly any activation whatsoever, illustrating that regular intake of energy-dense foods really reduces the pleasure you experience when you consume those foods.
The reward circuit is a region of the brain that controls the feeling of pleasure. It is particularly responsive to sugar consumption. But eating too much ends up weakening its responsiveness, so that at the same dose, the sensations of pleasure are ultimately reduced. And Eric Stice's experiment reveals another more subtle, perhaps more pernicious effect. After a diet too rich in sugar, the brain becomes hypersensitive to images of food.
The more and more you eat ice cream, the less and less the reward circuitry is recruited when you consume ice cream, but the more your reward circuitry is activated when you see cues that say you might get ice cream. So your reward circuitry fires up when you see an ice cream store as you're driving down the street, or you see a commercial for ice cream on the television, and the reward circuitry activates much more for people who eat ice cream all the time than it does for people who don't. And that prompts eating in the absence of hunger that drives obesity and weight gain.
This direct influence of food on our brain plays a crucial role in what we choose to eat each day. What happens in the brain at the moment we pick a dessert rather than an appetizer, or fish rather than red meat? Who is really pulling the strings? Carlos Ribeiro and his team are leading researchers on food choices.
What we really want is to find all the components, all the genes, the molecules, the neurons which direct feeding decisions. And for that, we have to be able to look at very fine and small effects.
The simplicity of this animal model, the fly, makes it possible to explore new avenues and new hypotheses. To understand the feeding behavior of the fly, Carlos Ribeiro has developed a machine that monitors the insect's choices in great detail.
When it's touching the food, which is in the other electrode, with its tongue, the proboscis, then we can measure that with the sensor here, which is the same sensor which you use on your iPad and your iPhone to detect the touch on the screen. Just that here, we don't detect the touch on the screen, but the touch of the food. And so we can really now dissect and analyze the choice of the fly, if she eats protein or sugar, but also when she's eating from the different foods, how it eats, how much it eats, how fast it eats, how often it eats, and really dissect all the details of the decisions which are controlled by the brain.
Thanks to this technique, he's been able to prove that the main reason for choosing food is, first of all, deficiencies. Naturally, flies that lack protein will choose protein-rich food. But looking more closely, Ribeiro observed that this is not always the case.
Sometimes, actually, we had some flies which didn't have this strong urge to eat protein. And then we were wondering why that was the case, right? And so when we looked at, it turned out that the flies which had no craving for protein had gut microbes. And so following up on many experiments, we could show that there are two specific gut microbes which, when they are in the fly, they suppress protein appetite, and therefore these two microbes have a very important influence on protein cravings in flies.
Flies, when choosing their diet, are influenced by the bacteria in their gut. This unexpected discovery raises an important question. Does the human intestinal flora, called the microbiome, also act on our brains? Do our gut bacteria play a role in our food preferences? At the University College Cork in Ireland, John Cryan does pioneering research on the microbiome. He's been able to prove that gut bacteria can influence certain behaviors in animals as well.
When you take microbes from highly anxious mice and transplant them to normal anxious mice, they become much more anxious, and vice versa. That even when you take them from normal, you can normalize the stress response and the anxiety.
Scientists now even consider the microbiome to be a kind of intermediary, a link between food and the brain.
The main factor that influences the composition of these microbes is the food we take. Diet and the diversity of the diet is really important from the moment we're born until we die in shaping the composition of the microbes. And so we're beginning to realize the importance that what we eat has on what's in our microbes and how that's influencing what's going on in our brain.
Our well-being depends, in one way or another, on our microbiome. A diet that is good for our mood is first and foremost a diet that is suitable for the bacteria in our intestines. This has led to the idea of using food to pamper the brain and maintain mental health. And it is the famous Mediterranean diet that has the scientists excited.
The traditional Mediterranean diet is really high in a diverse range of plant foods, so lots of different leafy greens and different coloured vegetables, but also fruits, very importantly legumes, so this is your beans and lentils and chickpeas, nuts and seeds, fish, and of course olive oil. Olive oil is a very important component of the Mediterranean diet. And we think that that diversity leads to more diversity in the gut microbiota, the microbiota that live in our gut. And that diversity in the gut has been linked to good health outcomes. We ran the first study last year where we recruited 67 people with major depression. They received dietary support with a clinical dietitian. Now, over a 3-month period, this trial took place, and at the end of that, when we measured their depression again, we saw that the degree of change in their diet correlated with the degree of change in their depression. So the more they moved towards a Mediterranean diet, the more their depression improved.
Using diet to serve the brain. It's an idea that's catching on. Scientists are now exploring all kinds of clues. Spices used for centuries in traditional Indian medicine are now being studied in labs for their benefits for mental health. Red fruits and berries have awakened high expectations. The polyphenols they contain might be able to rejuvenate neurons on the decline. Are red fruits and spices the miracle ingredients for eternally young neurons? It's still too early to say for sure. Researchers are only just beginning to uncover the secrets of the remarkable relationship between nutrition and the brain. The ideal menu for our little gray cells is still largely unknown, but a balanced, diverse diet which does without processed food and sugar and favors fruits and vegetables seems so far to be the best recipe for preserving the mental faculties.
My grandmother said, you are what you eat, so eat well. And what we're realizing now is that science is beginning to understand how true she was.
If we limited the deficiencies, would that reduce crime? Too early to say. What we do know is that when you bet on healthy eating, it has effects on behavior.
The more we overeat Snickers bars, we become hypervigilant to Snicker cues, and then we eat a lot of Snickers. And we create that monster in ourselves. So the best thing to do if you have kids is feed them healthy foods and not get them used to eating this kind of crap. I can't believe I just said crap, sorry.